Okay, let's look at question 2. Again, I've moved it to a separate document. Okay, given 4 minus 2x is less than 16, where x is a rational number, solve the inequality. Okay, so 4 minus 2x is less than 16. Okay, so how do we solve inequalities? Well, it's honestly much like solving normal equations. You start by trying to isolate the term or the variable. Okay, so in this case it's going to be minus 2x. So to do that, we'll bring 4 to the other side and then subtract it. So we'll have minus 2x is less than 12. Okay, because 16 minus 4. And then now we can just divide both sides by minus 2. Okay, so we'll have x, and then on this side we'll have minus 6. Now here's where the catch comes in. So whenever you have an inequality and you're dividing by negative, so here we divided by negative 2, the sign switches around. Okay, so now instead of being less than, it will be greater than. So there's your answer there. X is greater than minus 6. And then to test this here, you can substitute in that minus 6 into that there. So if I say 4 in my calculator, 4 minus 2 times minus 6, you'll see I get 16, right? So that means that in order for this expression to be true, right, in order for 4 minus 2x to be less than 16, I need my x to be greater than minus 6. So now instead of saying in your calculator now again, instead of saying 4 minus 2 times minus 6, let's try something greater than minus 6. Let's try minus 5. And you see if I do that there, I get 14. And 14 is in fact less than 16. So that means our answer is correct. Okay. The next question says, represent your answer to question 2.1.1 on a number line. Okay, so let's say I have a number line here going like that, and let's say at some point I have 0. So obviously minus 6 is going to be on the left of that, so we have minus 6, and we want x to be greater than minus 6, so x has to go that way. Okay, and since it's not inclusive, you can see that it's just x has to be greater than minus 6, not greater than or equal to. We leave the dot uncolored. So for this question, this would be the right answer, like this, right? But let's just say hypothetically that the answer was that, then we would color the dot in. Okay, but it's not, so we'll just leave it uncolored, and then that's the answer for that. Okay, the next one is 2.2, solve simultaneous equations. So our two equations are minus 2x minus y equals 10, minus 2x minus y equals 10, and 3x minus 4y, 3x minus 4y equals to minus 4. Okay, so how do we solve simultaneous equations? Well, the easiest way to do it is to firstly isolate one of the variables. So if we look at both of our equations, let's look at the coefficient of each of our variables. Okay, remember we have two equations, so that means we have two unknowns. The two unknowns are x and y. Okay, so now let's pay attention to the coefficients on each of those variables. So we have minus 2 for s, we have minus 1 for that y, we have 3, and we have minus 4. Okay, so just looking at that there, it looks like the easiest one to isolate would obviously be this one here, because there's no number multiplying it there, it's just a negative 1. Okay, so let's see how we can isolate that there. So let's bring y to this side here. Okay, so now it will become positive, and let's bring 10 to that side. So now we have minus 2x minus 10 equals y. Okay, so let's call this our equation number 1. and let's call this equation number 2. So now we tell the examiner that we're going to sub equation number 1 into equation number 2. Okay, so we have 3x. I'm writing down this equation here. 3x minus 4, and now in place of y, we put in our equation number 1. Okay, so minus 4 times minus 2x minus 10 equals to minus 4. Okay, and let's solve for that now. So it's 3x plus 8x plus 40 equals to minus 4. Okay, let's group our like terms. So we'll have 11x, and then I'll bring this to the other side. So we'll have minus 44 on that side. Okay, we'll divide both sides by 11, and then we'll get x is equal to minus 4. Okay, so now we can call this equation number 3. Okay, and then I'll come here, I'll just split this in half, and then say sub equation number 3 into equation number 2. Okay, so 3, and now again in place of x, I'm going to substitute in minus 4. Okay, so 3 times minus 4 minus 4y equals to minus 4. Okay, and so with that I'll get oh, and by the way, you can substitute this this equation number 3 into either of the equations. It doesn't matter. I think it would have actually been easier to go into that one, but it doesn't matter now. We'll just carry on. So we'll have minus 12 minus 4 equals to minus 4y here. Okay, again we'll group like terms, so I'll bring this minus 12 to that side, so I'll have minus 4y equals to minus 4 plus 12, which is 8, and then I'll divide both sides by minus 4, so I'll get y is equal to minus 2. Okay, so there's your final answers. X is equal to minus 4, and y is equal to minus 2. Now to test this here, I'll leave this up to you, I won't do it, but you can take these values that we have and substitute them into these original equations and see if you get the right answer. So for here you'll say minus 2 times minus 4 minus minus 2, and that should give you 10. And for the other one you do the same thing, you sub in x and you sub in y, and it should give you minus 4. And that's how you test if you got the correct answer. Okay, let's move on to question 2.3. So it says solve for x, and then we're given that equation x times x minus 5 over 6. So let me just write that down. X times x minus 5 over 6 is equal to minus 1 is equal to 0. Okay, so it's minus 1 is equal to 0. Okay, cool. So the first thing I want to do is I want to get rid of this denominator, this fraction. Okay, so the way to do that there is you multiply every single term by the denominator. Okay, so let's start here, x minus 5. Now think about this here. Let's say I started off with x times x minus 5 over 6. If I multiplied that by 6, all I would do is get rid of the denominator. That's why I just wrote down the numerator as the answer. Okay, and if I take 6 multiplied by minus 1, I get minus 6. And then obviously anything times 0 is just 0, so I'll have 0 there. Okay, and now you can see I'm going to end up with a quadratic equation because I'm getting squares here. So let's say x squared minus 5x minus 6 equals to 0. Okay, now we have a trinomial. So how do we factorize a trinomial? Well, we need to find our common factors. Okay, so the best way to do that there is to find a number, two factors of 6, or when you multiply these two together, in this case it's just going to be 6 minus 6, that when you multiply them you get that, and when you subtract them or when you add them you get the the middle term. Okay, so in this case, our two numbers are going to be -6 and +1. Okay, so if you think about that there, we selected -6 and we had +1. Okay, so if I add these two together, I'll get -5, which is my middle term. And if I multiply them, I'll get -6, which is my last term. Okay, so that's the two factors that I'll use, and I'll just break it up like that. Okay, so let's start with, now we're going to isolate these two terms. So we'll start with these two, and then we'll move on to these two afterwards. So let's start with the red ones here. X is the common factor. We have x -6, and then on this side we have no common factors, so we'll just factor out 1. Okay, so you see that if I multiply that there, I'm going to get x -6 again. Okay, and that's equal to 0. And now you can see that we have common factors, which is x -6, so I can factor that out, x -6 and x plus 1 equals 0. Okay, now obviously we're going to equate each of these to 0, and the reason we do that there is because, remember, we're trying to get this whole thing, or this side at least, has to equal to 0. Okay, and how, if you think about multiplying two numbers, right, let's say I have two numbers, a times b equals 0. Okay, the only way for me to get two numbers to multiply and equal to 0 is if one or both of these numbers are equal to 0 already. Okay, so let's think about that. Let's say I have 5 times 0, that gives us 0. Or let's say I had 0 times 5, that gives us 0. So do you see, one of them has to be equal to 0, or both of them have to equal to 0. And then that's the only way to get something, two numbers to multiply and give us 0. So that's why we say that either x -6 equals to 0, or x plus 1 equals to 0. Okay, so let's now solve for that there. So this is pretty straightforward. We're just going to have x equals to 6, or x is equal to -1. Okay, now again, to test if your answers are correct, you're going to take each one. So let's start with x equals 6, and then you're going to come to your original equation, and you're going to insert 6 in wherever there's x. You're going to substitute it in, and you're going to do it for this side here. And if your answer comes to 0, you're going to put all that in your calculator. If your answer comes to 0, then you know that you have the correct answer. And you do the same thing for x equals -1. Okay, I'll leave that up to you again. Alright, the next one says, we're looking at this one now, that solve for x if c equals to the root of a plus 2x. So 2.3.2, this was 2.3.1. So c equals to the root of a plus 2x. C equals to the root of a plus 2x. And we're trying to solve for x. So that means we're going to make x the subject of this equation. Okay, so the first thing to get rid of here, because remember the goal here is to isolate x on its own. So the first thing to get rid of would be the square root. Right, now how do you get rid of the square root? Well, you do the opposite of it. So let's say, for example, I have the root of a. If I want to get a alone, I just need to square a. Well, I need to square the square root of a, right? And then I'll get a. So let's square both sides. So I'll have c squared equals to, now remember, if I square that there, I'll just get rid of the square root. So I'll have a plus 2x. Okay. And now again, we want to get x on its own. So I'll bring this to the other side. So I'll have c squared minus a equals to 2x. And then I'll divide it both by 2 to get x on its own. So c squared minus a over 2 equals x. Okay, and that's the answer. Okay, cool. Let's look at now question 2.4. So it says, Tabello is currently 4 times as old as his daughter Linda. 6 years from now, Tabello will be 3 times as old as Linda. Calculate Linda's age currently. So this sounds like a very complicated thing, but in reality it's just asking you to convert these words into some mathematical equation. Okay, so let's think about this here. Let's call Tabello's age T. Okay, and let's call Linda's age L. And remember, you can pick any letters you want to. You can say X and Y, P and Q, or whatever. I'm just using T and L because that's their initials. Okay, so Tabello is currently 4 times as old as Linda. So T equals to 4L. Okay, so that's our first hint, right? And then the next one says 6 years from now. So you're taking T's age and you're adding 6, because in 6 years from now he'll be 3 times as old as Linda. So T plus 6 equals to 3L. Okay, and again this is 3L plus 6 because she's also gotten 6 years older. Okay, so now you can see that we have 2 equations again, and this looks like simultaneous equations, right? Because we have 2 unknowns and we have 2 equations. So I'm just going to rewrite those 2 equations down here. So this is question 2.4. So again, I had T is equal to 4L, and I had T plus 6 equals to 3 times L plus 6. So I'm going to read this question again. Okay, so let's see. So now we already have T as the subject of this equation. So all we have to do is substitute it in there, right? So in place of T, I'm going to put in 4L. So I'll have 4L plus 6 equals to 3L plus 18. Okay, and then I can now group my like terms and solve for L. So again, I just moved 3L to that side, and I moved 6 to that side and made it negative. So 18 minus 6 is 12. So that means, therefore, Linda is currently 12. Okay. And again, you can try and think about this in your head. Now, if you get an answer, test it out and see if it makes sense. So if Linda is currently 12, how will that make sense? We'll put it into the scenario and then see if that makes sense. Okay.